Welcome to the last day of foundations of programming. Typically we have 20 days. So I'm usually like, oh, welcome to day 20, but we had a Memorial Day, but that's okay. So last day of foundations of programming. It's Friday. You guys started the immersive program on Monday. I know you guys are excited. We'll try to keep today short if we can. Um, the last thing we really have to cover is Python regex and ASCII values. The last lesson, which is on the calendar, I never removed it, is typically like a challenge, like a speed challenge. But we no longer do it because when this program was created, the curriculum specifically, uh, you had like 12 coding challenges that you had to complete to like for CoderByte to get accepted to Platoon, and then that was changed to three. So like the last day consisted of us like trying to complete all of them within like one class to see how much you've learned, right? Because if some of us let me rephrase that. When I was coming in, right, some of us took months to do it. It took me 2 months for my application for me to finish it, right? And that's just a CoderByte challenges. Nowadays, you guys only have three challenges. Um, I wouldn't say it's easier, right? Because you still need to know how to code to complete all three. Um, it was just the 12 tend to deter people. They're like, oh, I don't know if I want to do all 12. It's a lot. So it was removed. We made less of them because realistically, we're not trying to like not get you to come in. If you can complete a couple of them, then I know you can code. And really, the live technical assessment tells us more about how you can code than challenges that we aren't even watching you do. So you could have easily copy and pasted the code, right? So what really mattered was the live technical assessment. So there's no reason to have such a huge gate of just challenges. But when we still had those, we would go back and do these speech challenges. So we're not going to do that. Our last official lesson will be Python regex and ASCII values. So regex, which is short for regular expressions, is a very powerful tool that comes with Python, and it allows you to essentially filter out or search for patterns in your text, right? The way that you are going to use it, and I kind of already hinted towards it yesterday at the end of class, is going to be for setting up user validation, right? So when you go to sign up for a website, whether it's Facebook, Instagram, or any other place, they typically tend to like ask you for like an email or a username, as well as a password, and they'll set restrictions for you. Like it's going to tell you a minimum of 6 characters, maximum set of like 16, something crazy like that, or 21. And then you'll need like one special character, one capitalized letter, one lowercase letter, and at least one number. And then when you try to put anything that doesn't fit the criteria, it's going to tell you it fails, right? So how does the computer know or the application know that you didn't give in the recommended or required input? Well, it's by a form of a validation. And typically what it's done is by using regex, right? You pass in input to the application receives this input, it runs it through a function that utilizes regex that has a specific pattern it's looking for. And if the input does not match the pattern, it returns false. If it matches the pattern, it will return true, therefore allowing you to create your account or not. So regex is going to come handling it within that um, part of the immersive program. It'll also help out with um not really that's the main thing we're going to be using it for in the immersive program. So you don't need to know, you don't have to be a subject matter expert. Really, like right now, as we're about to start, there's going to be a couple of things I'm a little rusty on regex because we don't use regex often. It's a powerful tool to know, right? But you don't. It's not something you're gonna be using every single day, right? So, what today's lesson really is gonna be an introduction to regex. We'll talk about the different functions or essentially methods that come with regex, so you're aware of the different capabilities of regular expressions. And then we'll do some practice problems, so you guys can kind of mess around with it. Um, and that'll conclude regex, and we'll move into ASCII values, which should take like 10 to 15 minutes, and that'll be all for Friday. Right, today is the last day, so we're not gonna go into crazy or whatever. We're gonna take it nice and slow, but still get some good value out of this. So let's go ahead and begin. So regex, as I've already told you, is a shorthand for regular expression, right? It is the acronym for it. And is it a method of searching a string for specific characters, right? Regex allows you to set a pattern, and it uses this pattern to search for your string. It's used for a multitude of different things like replacing, removing, finding, and matching parts of a string, right? Instead of like manually iterating through a string, looking for like hard coding, you iterating through a string and then checking every single character to see if it matches the criteria. Regex already has a lot of this functionality built into it, so you leverage the functionality that comes with regex. Also, remember, strings are immutable. So when you concatenate strings with the plus equals operators, you are not actually adding things to a string because you can't, right? Strings are set in place. When you essentially change a string, you're reassigning it to the same variable name. This idea applies to regular expressions, right? So if you use a regex um, method to replace something in the string or filter it out, really you're just recreating the string without that specific character or pattern that you added to it. It's nothing breaking, right? Knowing this information isn't going to make you or break you. It's just to keep you aware of how it's working. So you don't think it's just like, oh, regex can actually mutate the string. No, strings are still immutable. Nothing changes that. So common use case, I started off this conversation with this use case, right? How do we know if an email is valid, right? You would set some kind of regex that looks for alphanumeric characters followed by an asterisk. I'm sorry, not an asterisk, an at symbol. Is there a specific term for this? I don't know. The at symbol, followed by some kind of suffix to a website, and then ended by like .com, .org, .net, right? Somewhere around these terms, right? Um, so this is where you would see where regex is being applied to validation, right? Whether it's email, passwords, or just input in general. Right. This is also only, as I mentioned before, just an intro to regex. It really just to get your toes wet, let you know that this does exist. It is a tool you can add to your tool belt and something that you will be seeing later on. So regex, there's different ways of using it for different languages. For Python specifically, you're going to use the RE, right? You're going to start by importing the RE module, which is short for regular expressions, at the top of your file, right? It's like importing random, but it's essentially just importing regex. When using regex on a string with backslashes, just use a raw string. What's the word I'm looking for? Yeah, I'm sorry. I'll let you thought. So stuff like WT, right? And you saw this when we talked about what was it? Working with files, right? You guys saw some of these escape characters like new line, right? Or so there's these special sequence characters that you can utilize to do things like create a new line, add a space, or tab, right? So if you wanted to use that specific, backslash t to actually like use it like actual text, but not actually the functionality of it, then you would use the R to represent that this is a raw string, right? I don't want to actually use /t and make it tab like this. I wanted to actually type out the / in the t, right? So that's just something to keep in mind. If you encounter something like that and you want to escape that escape sequence or that special character, then you can use the R to ensure that it's raw. So the very first method we're going to talk about is going to be the sub method, right? Which I believe stands for substitute. Don't quote me on that, but I'm very confident it stands for substitute, right? This method takes a couple arguments. The first one is the pattern of what you're looking for, right? This is quite literally your regex expression, right? You want to create a pattern that you're going to use to load through a string, The second argument is what you're going to replace it with, uh, and then followed by the string itself that you're trying to look through. And then you have, I believe these two are optional. Yep, only three of the above parameters are required. Yeah, so uh, the last two, count and flags, are optional. Uh, count will substitute, I think by default it's set to 0 or 1, right? It'll look for specifically one item, but you're able to substitute multiple items that it encounters. Um, this is a much stronger method than using, if you've seen the method called dot replace. You've probably seen that around here. So dot replace and dot substitute are fairly similar, but dot replace isn't as powerful as the dot sub, because the dot sub you can apply a pattern, you can add count and flags and stuff like that. And the flags is, I don't remember exactly how the flag works. It's, I think, for example, like let's say you want to ignore capitalization. There's a specific flag you can add here to let it know, like, hey, I don't care if it's capitalized or lowercase, grab them all, right? So there's specific flags here you can set, pretty much like a setting for this method. But we won't talk too much about flags. You know, by default, there's no flags set onto this method. All right, so here is the first example of how the dot sub method works. So we have our string, which is, hey, look at this awesome string, right? It's just a very simple string variable. And then we're going to recreate a new different string, as I said, string called no hey string, right? And what's going to be assigned to this variable is going to be whatever returns from calling the method dot sub. We're going to pass in our pattern. We're looking for the pattern HEW, right, which spells out hey, right? We're looking for sorry, not W, Y. Oh man, I can't speak today. And no one said anything. Y'all just looked at me like, this guy's dumb. Yo, say something, correct me. So we're gonna look for the pattern HEY. And as you recall, the second argument is what we want to replace it with. So we're gonna replace it with an empty string. And then what string do we want to look through and replace? Well, it's going to be the sum string string, right? So these are the three arguments that it should be taking. The first one, as we mentioned, was a pattern, what we're looking for, to replace with what that we should replace that pattern with, and then the string that we're actually trying to look through, right? Afterwards, we print out no hey string, and as you can see here, it says, look at this awesome sentence, but there's no hey or hey, right? We didn't set a count, so by default, it grabbed every single hey that it encountered, right? That's when you might want to actually consider using the count argument within your dot sub to specify, hey, I only want to replace one out of all the heys that you encounter. Also, I want you to realize that there is a gap here, right? So we replaced it with an empty space, but there's still spacing that was between the heys and then the hey and look. So that spacing still exists here. So be aware of that. Here, the next code snippet, they do something different, right? Here, they actually add that optional argument, which is count, and they set it to 1. This time, we have one of the heys still remaining, so it didn't remove all of them by default. It still left one behind. So the count operator, although it is optional, it's still there for you to use if you like, as well as the flags. If you want to know more about the flags, you can just quite easily Google the flags for the dot sub regex method. All right. So here we have another string, and we're going to talk about exactly what we're looking at here in a bit. This string, although it looks a little cryptic, it says apple, banana, kiwi, and melon, right? The words here obviously have some special characters like the exclamation mark, numbers, the @ symbol, the hashtag, right? But we can kind of already make out what's supposed to be here. We're going to create a new string that's going to essentially filter out the previous string by only grabbing what we're looking for, right? Notice that we are going to grab A through Z lowercase, A through Z capital case, and there's this empty space here, but that quite literally stands for an empty space. And then once we grab that, we're going to save it into the alpha string, and that's what they're printing out. I'm actually a little confused how this one's working, actually, now that I think about it. Because this is a pattern, and we're trying to replace it with this. Huh.
I think it's not A through Z, not capital A through Z, and not space.
Yeah, I
One or
think that's
more
what.
occurrences of.
Yeah, I think that's what this caret is trying to represent. We'll talk more about these special characters in a bit. Um, for those of you who have never seen regex, we're going to talk about how this pattern works and the different types of patterns we can use. But this is the special sequence they use, right? The pattern that's literally the regex syntax to look for something, right? So like Nick mentioned, uh, it's trying to grab everything that is not A through Z, lowercase or capital case, and the spacing. I'm almost certain that this is what the caret is trying to represent. And then it's going to replace everything that's not this with an empty space, therefore filtering out the alpha string. If you don't understand what this is right now, that's okay. We'll talk about it in a little bit. All right, here we go. Actually, here it is. So we have the meta characters, which is the syntax that you're going to be using for your regex. These all have special meanings. And you already saw a handful real quick here. The first one's going to be the brackets, which stands for a set of characters. And your example, as you see here, is I want to get a set of characters from A through M, right? A through M. That's how you use it. You saw earlier that they quite literally put all the alphabet, so A through Z. And notice that they use lowercase, but they also did A through Z capital case. So they're trying to grab all occurrences pretty much of any of them. The backward slash signals a special sequence and can only be used to escape special characters. So normally, we think of like backward slash as like a tab of the new line. Here the backward slash is going to represent some special sequences, which are unique to regex. We'll talk more about them later. But we can see an example here, backward slash D, which if I remember correctly, this is going to grab all digits, right? That's what the backward slash D is doing. It's grabbing all digits. The next one is a dot, which is going to grab any character. Think kind of like Linux. Whenever you guys open up a directory in with VS Code in your terminal, you might type in code space dot to open up everything in your VS Code. It's something like that, right? So the dot is pretty universal in coding. A lot of times it stands for everything. So the dot here is any character except new line. So the example we see here for this pattern is we're going to grab any word that starts with HE, it ends with O, but it has two characters between these strings, right? So this could probably get hello, and although they're not words, but maybe like hepo, heto, hero, like whatever any specific pattern that there might be between the E and the O, it doesn't care. The only thing it cares for is that it should start with the HE, it ends with the O, but anything in the middle could be whatever, as long as it's not a new line, right? The next one is the caret, which is why I'm a little confused about this one. Typically, this stands for starts with, right? So we want to, if you want to grab something in the string that starts with a pattern, then you would use the caret That's why I'm a little confused with this one. I think because it's being used in combination with these brackets, it's working a
Yeah, I
little
think
different.
if it's inside the brackets, it means not. If you were to put it
Yeah,
outside the brackets, it would be starts with.
right. Um, Sorry, I'm a little rusty, like I told you, but for the most part, it's all coming back to me. But just like Nick said, right? Typically the carrots it means for starts with, but just like Nick brought up, if it's inside the bracket, it will change the meaning. So there's some kind of like special occurrences or some weird functionality here and there. So just be aware of that if you're struggling with uh the regex, or if you see a regex, you're not sure it's working. Some of these might work a little different together. The dollar sign is quite literally the opposite of the caret. This is for ends with, right? So they're gonna try to grab anything that ends with planet, right? Um, the asterisk is zero or more occurrences, right? So here they're trying to grab it's saying it has to start with HE, and then it can have zero or more occurrences of any character, right? Notice here there's a dot followed by the asterisk. So what this saying is any character, zero or more occurrences of it. So we can grab like um I can't even think of a word right now. Uh Helicopter. It could be a helicopter, right? So they might get actually no, it wouldn't be a helicopter because there's an O at the end here. What starts with HE and ends with an O? I can't think of a word. Anyways, just know, right, that it's gonna grab any word that starts with HE and ends with O, no matter what's in between these, right? Whether it's nothing or it's like 10, 15 other characters inside of it, right? The plus sign is similar to the asterisk, but instead of zero or more occurrences, it's going to require one or more occurrence. So there has to be at least one occurrence in there, right? Uh, yeah. Uh, the question mark is zero or one occurrence. So here the hello, it might be like one L or no L at all, right? Zero, one occurrence. So these three is typically is where what you use to kind of figure out how many times something should happen or occur or be in something, right? So these are going to be those markers right here. The curly braces is going to be exactly the specified number of occurrences, right? So here, once again, they're using the hello as an example. We have HE, and then it's going to be any character, but only two occurrences of it, right? That's what they're specifying here. Um, the pipe, if you know JavaScript, how we use like the OR method, right, is a double pipe. It's similar here. It's just one pipe though. So we're either looking for falls or stays, right? So either one of these patterns is available. And then we have the open and close parentheses, which is capture and group, which we won't get too much into. It could be a little confusing. But before we continue, I want to actually take a look at how these meta characters work. So what we're gonna do is I want you guys to open up your browser, and I want you to look up regex 101. Regex 101 is my go-to website when it comes to building regex. You might have regex 101, or some of you might see in regex 1. It's another one. I like regex 101. It's a lot better. I like the interface. But regex 101 is essentially just a quick website that you can go to help you build your regex patterns, right? So when you get here, all you have to do is change the flavor, which is just the language that you want to be working on. So we're going to move it to Python. Um, and right now we're just setting it to match. We want to match something, right? So I can say something like, let's see, I want to capture. Mm, Give me a string. I can't think of anything right now.
At gmail.com.
I don't want to use that because that's going to be part of the assignments. We're going to say, where is the library? All right, we'll just use it right in the string. Where is the library? Right. Uh, and here is a string that you're going to be essentially parsing through or trying to, go through. The expression for your regex is going to go on the block above. And here is where you would start the pattern. So let's say I'm trying to look for it's actually, let's just use at gmail.com. I think that's a much better. You're right, Nick. This is too easy. We're gonna say Nick O'Brien at gmail.com. Right. Now, I want to make sure I can capture this email. So how would I do this? Well, let's start with, I want to grab A through Z, lowercase and capital letters. I'm gonna put this, it's gonna be a set of characters, right? So I want to grab a set of characters, A through Z, capital case or lowercase, either or, because Nick might be a little weirdo and have like capitalized letters here too. So who knows? But I want to grab a set of characters, and the set of characters I'm grabbing should be lowercase or capitalized alphabetical letters, right? And we can already see here that it's grabbing stuff. Now notice that the string here, or I guess the color coding of my string, it's alternating. It's like a light blue and a darker blue, light blue, darker blue. It does that because it's trying to specify or show me that each one of these is an individual match. Why do you think it's grabbing them one at a time?
Because it only looks at one chart at a time.
Right, as it stands right now, I only have it set to, I want you to find just one letter, A through Z or capital A through Z, and it's finding every possible match, right? So we can either add the asterisk, which is going to match 0 or more occurrences. And notice here that it changes the grouping right off the bat. So the first group or the first match it has is everything between the start and up to the asterisk, because we're only trying to capture A through Z, capital and lowercase. So it's not going to grab the at symbol right afterwards. So this is one match. Then there's this is being split up here with the asterisk, the at symbol and the dot. So the next match is Gmail, and then the last match is .com, right? Or the com in general. So here we have 3 different matches that we possibly have, but we want to grab the at symbol, right? So how do we do this? Well, I want to make sure that I can grab A through Z, capitalized or lowercase, which is going to grab the first one. But after we capture the first part of the email, this needs to be followed with an at symbol. I think we can do that. Yeah. Yeah, all one match. Right. So what this is saying is, hey, the first part of my string needs to be capitalized or lowercase alphabet character. Right. It needs to appear 0 or more occurrences, which is not accurate. There should at least be one character here. So let's replace that instead of 0. I think, what was it? Was it plus sign? One or more occurrences. Yep, it's a plus sign. So instead of an asterisk, I'm gonna switch this to a plus sign because it has to have at least one character here. Because then email doesn't have no characters before the at symbol, right? So A through Z, lowercase or capital case with a plus sign, followed by an at symbol, and then it needs to be something like Gmail. It could be Hotmail. It could be something crazy, right? It could be at mail.mil, right? I think, if I remember correctly, how the emails go, at mail.mil, right? For the military emails. So it can be anything, but it has to be, I don't know every possible email out there, email domain. But it probably will be alphabet. So I'm going to say A through Z, A through Z. So it has to find, my pattern needs to start with a capital letter or lowercase, one or more occurrence, followed by the @ symbol, followed by another set of alphabet letters, followed by a dot. Right, and notice I put a backward slash here because the dot is a special sequence, right? It matches any character, but that's not what I'm looking for. I'm looking specifically for that period character, right? So I'm using the escape sequence. Now it says matches the character dot with index, so on and so forth, whatever. And then after the dot, I need to end it with like .com or .org or something like that, right? So it's gonna be once again, it should be A through Z lowercase. We'll say, maybe set it to like 2 characters minimum. No, we'll say plus. But this pattern right here captures my entire email, right? So I just created my pattern to be able to capture Nick O'Brien's email. Now, obviously, this isn't perfect, right? This is very generic. We might actually want to add some more restrictions to what we're actually gathering. But this is a good start to really show you how you would build your regex pattern. And regex 101 is going to be a great website to do this. That way you don't have to open up a Python file and try to work with Python. You can just come to the website and kind of mess around with your regex to see if it's going to capture what you're looking for, and then you can add it to your code. So definitely bookmark this webpage for you, so you can use it once you guys get into the immersive program, so you have it easily accessible. But this is a very good one. If you forget some of the stuff, you can come down here and you have like a reference, right? You can also see that as I was typing out my regex expression, it was giving me an explanation of what my regex was doing. So it's pretty cool. So if you like Google or look up any kind of like regex pattern and you don't know what it's doing, you can bring it here and it'll break it down for you, piece by piece. Right. So definitely a very cool website to use, and what I recommend you guys use for the remainder of today's lesson. Do I have any questions so far? None. Who's his first time seeing regex? Dominic. Dominic's like, yo, what the heck is all this? Okay. Yeah, regex really helpful. Let's go ahead and come back. So we talked about the meta characters. I showed you some of these in action. Let's go ahead and continue. But here we see once again an example of using the dot sub method, right? This time it's a different string, right? So the string says learn to program because programming is cool. We're trying to find the word program and we want to replace it with dance, right? So we can say learn to dance because dancing is cool is what our goal is. But notice it doesn't give it exactly what we're looking for, right? It says learn to dance because dance mean is cool. This M is an extra M that comes from the whole programming word, so it's a little weird, right? It doesn't give us exactly the functionality we want to do, right? So you can use meta characters to handle optional things, right? And here's the next example below where they add the program pattern again, but this time they add an extension of the MING for main with the question mark. In the event they encounter a word like programming instead of just program, right? Still, it doesn't give us exactly what we're looking for, but it's a little bit better, right? Learn to dance because dance is cool. Whereas before, dancing doesn't even make any sense at all. So this is just a quick example of how you can use the meta characters that we talked about to handle different situations. You can also use this in a function. I'm not even going to begin how to break down how this works because it's going to confuse me too. I hate explaining this part. But if you want to use it in a function, you can definitely use it in a function. I hate the match method specifically. I really hate it. Match.group. Just the only thing you need to know is that in this code, they're passing in what they're looking for, right? What they're looking for is the the term program, right? If for whatever reason, when they find a match, if it's programming, they're gonna return dancing. But if it's just program or anything else, that's according to that match, we're gonna return dance instead, right? And that way we're able to get over that little issue that we encounter where instead of just saying dancing, it just said dance, learn to dance because dancing is cool. So you're able to add some more functionality to be able to give it those optional condition statement in the event that we get programming. Really, what we're doing here is we are passing in the function, right? Replace here instead of the actual pattern that we want to replace it with. So when it runs the re.sub method, it's going to run this replace method. It's going to pass in the match that it grabs from the dot sub in here. Let me show you. Let's remove this. I'm going to say Gmail. When you use parentheses, notice that when it grabs a match, it puts it in a group, right? It puts it in a group. Here it shows group 1, but I believe when you run the code, it starts the group using 0 indexing, which is why it says like group 0, or sorry, not group 0, match 0, match.group 0. So although regex 101 is showing you that's group 1, really in code it should be index 0, because it's going to return to you almost like a list-like object of every possible group that you found. So when it grabs program, if the one of them is programming, it's going to return dancing, right? I know it can get very confusing. Just understand that we're putting this in a function and changing the functionality of how it should replace the program word. Any questions? You're going to be using regex in a similar method like this. We're going to pass it in a function. Just be aware of that. An example of the flags parameter, right? So here we have another string. We have, hey, you, yeah, you, I love to code. They're still using the sub method, but here we give it optional wording where it's like, I love to code, right? With the or meta character here. And we're going to replace it with ski, right? So if we encounter any of these, we're going to replace it with ski. But notice that when we run this first line of code, it doesn't change anything, right? Because we're looking for the pattern of I love to code in lowercase, whereas the string has it all in capitalized format. So this re.sub method really isn't going to do anything because it won't be able to capture this. So that's where the flag kind of comes to play. Here's I knew there was a capitalization flag. Notice here they add the flag that we saw earlier, which was an optional argument. The flag they gave it was ignored case. So when it runs this substitute method, it's going to ignore the fact that I love to code is capitalized. It's going to treat it as a lowercase method, so it matches our pattern. And now we see here, hey you, yeah you, ski ski ski. Right, so it works. So this is a way of using flags. There's a handful of other flags you can find. If you want to look into those, you guys definitely can. Just check out the documentation for the regex module for Python. The dot replace method, I brought this up briefly earlier. You might have thought to yourself, if you use the dot replace method, well, Roger, why do we use regular expressions if we have the dot replace method as well? Well, the dot replace method is very limited, right? Here we're able to switch out love with the word hate, but it's, as you can see, it only has 2 different arguments. It won't be able to pass in a regular expression that optionally changes different things, like the substitute method for regex. So pro tip, forget about dot replace, master the substitute module instead. For regex, it's a lot more powerful. So they're similar, but dot replace is very, very limited, where substitute gives you a lot of different functionality for different scenarios. The find all is the next method we're going to see here. The find all scans a string from left to right, searching for all non-overlapping matches of the pattern or string that is passed in, and returns a list of matches, right? So here we have the string, hey, you, yeah, you, do you love to code, question mark. And we're going to find every occurrence of you, and then it takes into argument of what string you're trying to parse through, and it saves the result into the variable called code string. And when they print out code string, we see here it's a list of every possible U occurrence that it encountered. You can also pass in the meta characters to get anything between A through E, right? So here they run the find all method again. Instead of adding the actual pattern U itself, we now gave it a much more flexible pattern using the regex syntax. And we grabbed anything, any character that goes from A through E, right? And here you have it. Finding all digit characters, I talked about it briefly when we were going over the meta characters, but there are some special sequences that you can use. The lowercase d is going to find all your digit characters. And you want to be very specific of what digit characters, just like you find the A through Z to, or how you use A through Z to find all the alphabet characters. You can do the same thing for numbers. You can do 0 through 9. And or 0 through 5 if you want to be a little bit more limited to what digits you're looking for. Or if you just want to find every possible occurrence of a digit, you can just pass in the \c. And as you see here, it's going to find the 2 and the 0, and it returns that as the pattern that it found. Here is a list of these special characters, right? So we talked about one very briefly as well, which is a dot, which matches any character except new line. The lowercase d matches a digit from 0 through 9. The capitalized D matches all non-digits, right? So everything that's not 0 through 9. And here we're seeing an example of using the caret again in the brackets. So this is the same as saying everything that is not 0 through 9. The lowercase s matches a white space character, right? So the tabby, the new line, I don't know what the F or the R do, if I'm being honest with you. Does anybody have anybody use these?
I think R is carriage return. I think it's a leftover from typewriters they used in the early computers. I don't know if it's used anymore.
Okay.
I have no idea
Yeah,
what F is.
I've never had to use RF, so I'm not quite sure. And then capital S matches non-white space, right? So there's pretty much a two different sides to this coin, whether you want to grab the actual digit or no digits. So there's like, you could do both. And the W is every single character, right? So instead of hard coding A through Z twice for lowercase and capital case, and then 0 through 9, and then the underscore, you can use a W to match all these. So these are essentially shorthands, so you don't have to type this long pattern in. Whichever one you use is up to you. There's no right or wrong answer. Whatever helps you read your pattern a little bit better. So here we're using the find all method again. They're using the string hello, heyo, hebo, and hekyo. We're seeing the HE example again. As you guys recall, the dots represent all characters except new line. So when it parses through the string, it's going to find everything that starts with HE and ends with O. And has at least 2 occurrences of any character whatsoever. So it captures hello, heyo, and hebo because this matches the occurrences, but it doesn't capture hekyo because hekyo has 3 characters instead of 2, right? And that's not what we specified in our pattern. Mm, 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 mm. Find iterable with every match object. So returns an iterable with every match object. What's an iterable? I've used this term so many times, right? It's something that you can kind of loop through, right? Like a list, a sequence of stuff, right? I've used it when talking about lists or dictionaries or strings. It returns a form of an object that you're able to iterate through, right? That's what iterable is. So this is gonna find everything like hello and gonna match them all together where you could iterate through them. Uh, it's a match object, right? And what do we know about objects? They have certain data attributes, certain methods, right? This data attribute for the match object has data attributes like span, right? The span depicts where it was found, and then the match attribute is quite literally the item that you found. Essentially, when you run the find iterable, it's gonna find something and create a match object of it, and you can iterate through your objects and print them out, right? So here, when they iterate through all the match objects they find, you can see here that it shows you that little code that we were seeing when we were going through object-oriented programming when we print out an object, right? It's doing that here, right? It's returning whatever the definition of this object is, which is a match object. And it has a couple attributes that it prints out for you, which is a span. And if you look at it, the first one, which is hello, is referring to this part of the string. And the span matches where it starts and ends, right? It starts at index 0 and it goes to index 5, right? So 0, 1, 2, 3, 4, 5. So up to but not including that end part, right? So this is it's telling you where it encountered that the match of hello, and it does the same thing with the other hello here. It starts at index 19 and goes up to index 24. So find iterable will find you every occurrence of it, and it'll make it into an object. So you have something like this already pre-built with the location of it. Match uh returns the match object only if it's first in a string. This is quite self-explanatory. So when we run the dot match method, right, we're trying to match for the word hello. But hello isn't in the beginning of the string. It's somewhere about 2/3 of the way in. So when we print out whatever comes back in matches, we only see none. But the match here does work because they encounter hello at the start of the string, so it actually does grab it and save it to the beginning. The dot search is kind of like the find method, right? Um, it searches the string for the first object match that it encounters. So here, hello, although it's not the beginning of the string like the dot match method, it's still able to find hello and it shows it for you. Here we have two occurrences of hello, but it doesn't find the second one. It was only going to grab you the very first one. Essentially, search is just it's a similar method like match, but it doesn't restrict you to the start of the string. These are all objects, right? We're still being able to print out the object and see where the span is at. The dot split method, uh, we we have a pre-built in method like this already, that we use pretty often. I know I've used it a lot, right? But the RA dot split method, you pass in a pattern of where you want to split it, uh, and it's gonna split it for you. Right, so hello 1 2 3 4 5, and then the hashtags, they're all separated by the @ symbol, so it's going to split the string at every occurrence of the @ symbol. How is this different than a regular dot split method?
Regular dot split method splits everything into chars, and then you'd have to rejoin them.
Yeah, you would have to rejoin them. I think also it's limited to the fact that you can't pass in a regex pattern like you would here, right? The fact that you're using that split method with your regex module allows you to give it a very specific pattern. where the dot split method, I think you're very limited to
Mhm.
you would have to hard code exactly what you're looking for. But what if you want to add an optional argument that you want to look for using regex? So regex is just a much more powerful version of the dot split method. So uh, essentially, if you want to have a little bit more functionality when you split your strings, use the regex version of it. But at least now you know that this is something that you can use. The match object utility. So we were printing out the objects earlier in the previous slide, right? They're using the find iterable method again. But this time, instead of just printing the entire object, notice that they're calling a method, right? Match.span. So this is a method that comes with this object. And instead of just printing out the entire object itself, it's essentially a getter function, right? It's returning to you the data attribute of span. So as you see here, as we iterate through our list of different match objects, we're printing out the span attribute that belongs to the object. So that's what you see here, 14, 19, 26, and 31 of hello. Right, so you are able to use those kind of getter functions that come with this match object. You can also do very specifically the dot start or dot end of where the match is at. If you just call the dot span, it's going to return to you both the start and end point. But if you don't want both of them, you could just say dot start or get it where it ends. So you get a little bit more specificness in this method here. But they're still just utilizing the method that come with the object itself. The groups, the groups or individual matches become important later. This one, I'm not quite sure exactly why this one works the way that it is. We'll put a pause on this one. I'll come back to this one. I don't use this one often at all, so I'm a little rusty on this one. We'll come back to this one. But up to this point, I just want to make sure that I reemphasize, if you feel a little overwhelmed with all these different methods, you don't need to be overwhelmed. You're not going to use 90% of them. It's really just to introduce you on the fact that these exist. So if you ever find yourself in a situation where you want to parse through a string or find a specific pattern, just know there's different methods that come with it for you to practice. You don't have to be a subject matter expert at this. Just know that this is a function that comes with Python that you can leverage for the future. Typically, what you only going to really need regex for is just the sole fact that you're able to look for a pattern. So you might want to find something, right? That's all. Find iterable, getting specific number of characters in a row. So this is just leveraging the curly brace attribute, right? So they're trying to find any digit, but the digit has to be 4 digits in a row, right? So it doesn't match the 14, but it will match the 1, 2, 4, 5 because it matches the regex expression of 4 minimum, right? Notice here they're also able to add 3, 5, right? So here they're looking for digits once again, but it has to be a 3 or a 5, and we get 1, 2, 4, 5, but we still don't get 14. So you're able to specify the start and the end of, I believe it's the range, right? A range between 3 or 5 characters, right? Where we still don't get 14 because it doesn't meet that range, but 1, 2, 4, 5 is still being able to get captured. All right, enough talking. Let's actually give this a try. It'll make a little bit more sense when you actually work through these. Let's go to regex. This should be lesson 14, vowels and domains. Oh, complete the following exercise that you haven't already. Stand by, let me make sure I don't have the answers. I don't want to show up to you guys. All right, there we go. All right, so there should be 2 exercises here. Write a function that uses a regex expression to return a list with all the words that start with a vowel. Right. So here's your input, and this is what the output should be like. What method do you think you might want to use from regex to solve this one?
Find all.
Find all. Right. That's a pretty good one to use. The next is going to be write another function that uses a regex expression to return a list of emails that all have the domain of Gmail. You probably want to use the same one here. Use regex 101 to create your pattern, so you can actually try this out. And we'll take about, how many minutes do you guys think we'll need? Actually, it's 6:30, so we'll take our 10-minute break, and then we'll restart at 6:50. So you get 10 minutes. I think that should be enough time. But take your 10-minute break, and we will continue at 6:50.
Okay. So first thing, import regular expression. Otherwise, none of the module will work. I need to write a function that uses a regular expression to return a list with all the words that start with a vowel. So here's the example. Here's the desired output. So function defined, it receives a string, and it returns regular expression dot find all. I always do the raw string thing because the escape characters will do weird stuff without it. I did /b for the beginning of a word, and then the I guess group of characters I'm trying to capture, which are inside the brackets here, are lowercase a, e, I, o, u, capital A, E, I, O, U. And then after it finds one of those at the beginning of a word boundary, it's any number of word characters after that. So /w word characters, and the asterisk is any number after that. So if I run it, it gives me the output. So it finds errors unless and explicitly and puts them all in a string or in a list and returns it.
Nice. Okay, cool. That's a good one. The backward slash B, I always forget that special character.
Yeah, it's not included in the slides, and it's one of those things that it can be really hard to do anything without knowing that.
Yeah.
It's or at least it helps a lot. It makes
Yeah,
the
yeah, for sure, for sure, for sure.
it's like you almost need like a big cheat sheet to do all this because there's so many different little tips and tricks. And once you have them, it's really not so bad. But anyway, okay, the second one, write another function that uses a regular expression to return a list of emails that all have the domain of gmail.com. So that's confuses my brain, but I looked at the input, so it takes a bunch of random domains, xyz.com, abc.com, and cisco.com, and the output wants the, I guess, whatever's in front of the @ to stay the same, but everything behind it to change to gmail.com. So in order to find all these strange domains, wrote the function, takes in a string, it returns regular expression dot sub. And so once again, the pattern to look for is the raw string of, I did the @ symbol. So everything after that, or so @ symbol. Then I did word characters. And actually, technically these brackets aren't needed, I don't think, but I'm gonna leave them there for right now. Word characters, one or more occurrences. Then the dot for like .com, but just like you said, you have to have the escape character in front of it, otherwise it'll match to any character. Then, once again, I did word character, one or more occurrences, and it grabs all of these. Oh, and then the other arguments in sub are the string that you're going to replace everything with, the string you perform the action on, and then since it wanted it in a list, I had to split it all by space because it's just a string otherwise, and that turns it into a list like it wants. So let me run it, and the end result is a list with all of the emails at gmail.com now.
Nice. Good stuff. Yeah, it's a very powerful tool. I love regex. Thank you for that. All right, let's go ahead and continue on. A way to treat multiple chars as a single unit. So here they're using the find iterable method again. We have hello 1 2 3 4 5 followed by pound signs as our string. The pattern for the find intervals are looking for three different groups, right? And I know it's three different groups because it's three different sets of parentheses. The first group needs to be anything from A through Z, lowercase or capital case, one or more occurrence, right? Um, so this will probably just capture hello. The second group is going to capture 0 through 9, one or more occurrence. And then the third group is capture everything that's not a digit, one or more occurrence, right? Which is going to be the hashtags, right? And then you see here, once they run this, they got multiple different groups. The first group at index 0 should have the complete string. Because if they're, I'm assuming it's because they're doing this, right? Because they have the whole thing right here. The second group is for letters. The third group is for numbers, and the fourth group is the special characters, right? Um, and we have the complete string because the first one overall we're grabbing the entire pattern as a whole, and then these individual groups do their own functionality, so they make their own matches as well. Right, and then we're able to see here that they print out really not really an interpolate string or format string. They just print out two different values. One is a string with complete string followed by the group at index 0, and then the same thing for everything else. So you're able to capture different groups of patterns using the parentheses. To be completely fair, I've never really had to use this. If you're working with data often, I can see why this will be useful, but I've never worked in the data role having to look for stuff like this often. So I've never had to use it. But it's nice to know that this is something that you can use. And then now finally it's gonna be the actual regex practice.py. We'll do a couple of them. Because if you look at the regex, let me remove the answers. That it's a lot. Oh, I don't have it done. Okay, good. So the last assignment for regex is really a one big assignment with 20 different problems. So this will give you guys more than enough practice. We're gonna do a couple of them. We'll take about 20 minutes to really give these a try. We're not gonna do all 20 of these today. Right, these you can do them off camera on your own if you want more practice. But really just kind of get your feet wet with regex to give you a try. More than enough exercises. Just start from the beginning and work your way down. We have how many people? 1, 2, 3, 4, 5, 6. I don't. Daniel, are you working along? Daniel Bittner, are you working along with us, or are you busy?
Yeah.
Okay, I don't know what that means. So you are working along. I'm gonna go ahead and assume that's a yes. So what we'll do is we'll take 20 minutes. Ideally, I want every one of you guys to present one of these problems, and then that'll be it for regex. So it's 6 of you, so let's work up to 6 questions. Let's go. We'll do this. We'll work for 30 minutes, 5 minutes per question, to really give it a try, and then we'll come back at 7:30. We'll present a question each just to make sure that you guys understand what you're working with. And then we're going to go into the last part today, which is going to be ASCII values. So let's go ahead and pause the recording now.
Which two?
Whichever one you decide.
Oh, man. Scroll to the bottom.
Just don't do the ones that I did.
Well, that's what I'm thinking. I'll pick some of the later ones unless somebody did those work from the bottom up. Okay. Let's do the very last one. So the prompt was write a function that uses a regular expression to return the Boolean true if the string passes in the string passed in has proper punctuation, otherwise return false. So for the example, the quick brown fox jumps over the lazy dog with no period would be false, and the same sentence with a period at the end of it would return true. So what I did is my function punct, it takes a string, and I did if regular expression dot search raw string. I did the brackets. I did a period, question mark, exclamation points, because right here it says a proper punctuation can be more than just a period. So this covers all three of those for the end of a sentence. Close the brackets, and then $sign for end of the string passed in. And then the second argument in search is the string that we're doing the search on. So if that returns true, the search, then return true on the function. And if none of that goes through, then you return false for my function. And so the two checks, the sentence with the lazy dog, no period, sentence with lazy dog, period, run it, and you get false true. Same thing that the prompt says you should get.
Nice. Okay, what's the next one? I'm assuming the one right above it.
Sure, make things real easy. What's this one? Write a function that uses a regular expression to return the Boolean true if the string passed in has one uppercase letter followed by a lowercase letter, followed by lowercase letters, otherwise return false. So example inputs, all caps Python would be false. An input of capital A, lowercase a, capital B, lowercase b, capital G, lowercase g would return true. So what I did was I made a function called upper lower. It takes a string, then exact same as the example I just showed, if regular expression dot search raw string. And what I did was this right here. So bracket A through Z. So it captures any capital letter. And then following it should be bracket A through Z lowercase, capitals any lowercase letter. Close out the regular expression pattern. And then the second argument is a string. If that comes through true, then you return true. And if that there's no hits on that, then you return false. And so if you run it, you get what it says up here. So when you pass in Python all caps, you get false. And if you pass in capital A, this jumbled thing, you get true.
Nice. All right, good stuff. Thank you, Nick. Let's go ahead and move over to Michael Scotto.
All right. Can you guys see this?
Yes, sir.
Wonderful. All right. 16 was pretty easy. That's why I chose it. But basically, write a function that uses regex or regex expression to return a string with all the lowercase letters removed. So here's my string that they give you. And then the output is basically everything only uppercase. I used the sub method. And then I basically just said A through Z with no uppercase, and then return that as empty, get rid of it. And then I pass in the string, pretty simple. And it produces what it expects in the output. Nothing surprising there. We can do this one. So let's see. Write a function that uses regex expression to return a string that has all words that are between 1 and 3 characters removed. So words like the and fox are going to be removed, etc. This one's a little bit more confusing. I had to look some stuff up here, but basically the B's are going to be the ends of the what it's looking for. The lowercase w is all alphanumeric characters, and then 1 through 3 is the start and end of how long the characters we're looking for are. So that will get rid of, or that's basically going to pull up all of the words that are up to 3 characters. And then the lowercase s at the end is for the white space. And basically the same thing, replacing it with an empty quotes and the string, and then I use the strip method to get rid of the white space. I don't think it worked perfectly, but that's what I came up with. I have this like little space back here But other than that, it's it got rid of all of the words that are too small.
Why's your space?
That I don't know. I have to
Oh,
mess around with the.
it's replacing the dots? Is that what it is?
I don't think so.
No, it's not. Never mind. It replaces dog with. Oh, it doesn't remove the. That's why. Because there's a space between dog and lazy, and it keeps that space there.
That's what I thought the what's it called?
So
The
maybe put like
S
a
would be.
maybe put a space here and a question mark, and the event starts with a space there.
Like here.
Yeah, yeah. Try that. Let's see if it works.
Oh,
Close.
oh, got rid of all of the spaces in between. What is only the question mark to?
It's
No.
optional. It's
Okay.
optional if it starts with an empty space. That's what it's saying. But I mean, that was a good try. But good stuff. That's nice. I like this one.
Okay, thanks.
This one is a very confusing one. Then last one, either Dominic or Daniel. I'd rather get Dominic in here. Dominic, you got two that were not covered?
Sure.
All right, let's get it then.
Can you see my screen?
Yes, sir.
Oh, I guess I'll start with the first two since everybody else did the other ones. Array function that uses regex expression to return a boolean true. The string that is passed contains only upper lowercase letters, numbers, and underscores. There are two strings that we're passing through. The full match, I had to like try a lot to like I was using the bracket notation, putting in numbers or whatever. And I found that this just contains I don't even know where I looked that up. It was just on a website. But it still contain what we're looking for, upper lowercase numbers and underscores. And then it'll return true if it's a full match. So if the string is only those what we're looking for.
What the heck? I've never seen the full match method.
Yo, again, I have no idea what was going on for most part. This is what I got stuck on the longest. But after like figuring out how things are written out and whatever, the rest of them were not easy, but I kind of got the hang of it.
Okay.
But you can see that it works. The one with
Sure.
spaces and a period returns
Yes.
false, and then the one with just upper lowercase and underscores and numbers turns true. The second one, write a function that uses regex expressions, return boolean true if the string that is passed in starts with the number 5. This one we just match, search for beginning of our string. And if it's a 5, it'll return true. Pretty simple.
Nice.
You'll see the one that starts with a 6 is false, and the one that starts with a 5 is true.
Nice. All right, good stuff. Good stuff. Okay. Good job, guys. I appreciate it. That was good. Let's go ahead and finish off today's class. That's going to conclude that one. Really, we're just going to really good talk about the ASCII values. It's such a simple concept that I don't want to waste anybody's time on manipulating the ASCII values. I just really want to talk about them so we understand that this is something that you might encounter or see. All right, so ASCII values, ASCII, right, pronounced ASCII, stands for the American Standard Code for Information Interchange, right? It's really just the representation of characters, but in their number formats, right? So there's a much more diverse chart out there. This is just like a small brief example, right? Notice here that they have A through Z capitalized letters, and there's a numerical representation of this character, right? There's also a numerical representation for the lowercase versions of A through Z, right? There's also other stuff here, like you can see, I believe this is like the backtick, the @ symbol, the caret, underscores, the brackets, even the delete button, right? These all have numerical representations. Here is a much more diverse chart. I believe this is the entire chart of the ASCII table, right? There's 128 different characters. You see here that the decimal and then the hex version of the characters and whatnot. A lot of these you'll probably never even have to use or think about, like all these right here from 0 to 31 really. But it's helpful to know that your letters, right, and all these other characters that you might have used frequently, they all have a numerical representation. ASCII is a subset of Unicode. Unicode is a universal character representation for text and computer processing, regardless of platform, device, application, or language, right? So every character in every language, even emojis, have a number representation somewhere in the Unicode standard, right? And you're actually able to manipulate your characters using numerical values. So I believe Daniel was talking about it earlier. So you're able to convert a character to its numerical value, as well from the numerical value back to a character. And here we see a small example of that. We have a string called alpha lower, which is just a string of ABC. We iterate through every individual character, and then we're printing out the character, but notice they're doing a typecast, right? Just like we convert stuff from to strings to integers, or vice versa, we can convert a string, or essentially a string, to its ASCII value, right? Using the OR function, right? The OR function turns a character into its ASCII value. And we see here the string itself, after they get each character here, they convert it into its ASCII value, and they're printing it out. In A prints out 97, B is 98, C is 99. And that is that directly matches the table here. 97 is the numerical value for char. I'm sorry, for A. 98 is for B, 99 is for C. And the same way that we're able to convert the string into its ASCII representation, we're able to do that with numbers as well, right? So here is the other side of the spectrum. We have a list of numbers. We iterate through every single number from this list, and we typecast it using the CHR for character to change this integer into its character representation. 65 is the start of the alphabet in capitalization format in the ASCII chart. Here we see it. 65 is A, 66 is B, and 67 is C, right? And they print it out. So you can go between both of these back and forth as you like. You won't really find much use for this. It's just good to know that this is a concept. Daniel was talking about how he used this to like manipulate strings. Right, so ASCII is helpful for coding challenges. That's probably where Daniel used it. Right, so you can shift certain characters in the alphabet, converting the characters to their ASCII values, applying some arithmetic, it can allow you to change a character to a different character, right? For general awareness, ASCII was the first major character encoding system for data processing. Remember that from the GUI to the memory on your computer, there's a lot of layers of abstraction. That's just another version. And I mentioned it before, but really regex and ASCII, you don't have to be subject matter experts at this. Just know that they exist. These are concepts that you can use. And if you ever find yourself in a situation where you might have to manipulate alphabet letters in a string, or if you honestly you might see a problem like that, where it's like, convert every vowel into 0 and every non-vowel to like a 1. How you would do that, you would like go through, you wouldn't necessarily check if is this number or is this a vowel or not, and then so convert it to this. You can use ASCII to move things around. That's a very vague explanation how you might use this ASCII concept, but there is essentially challenges out there that you might encounter where it's going to tell you to convert a letter to something else. That's when you would use the ASCII concept. Regex, I already told you how you're going to use that when it comes to validation. But really, you're not always going to find yourself in a situation where you're using ASCII or regex very frequently. Regex, you'll use it more frequently than ASCII for sure. But it's not something you're going to be using every single day, right? It's very unique, special occasions. It's just important that you're aware of that, so you know that this is something that exists. Now, we're not going to do the problems because the problem is really the same thing that you saw in the slides. And I don't want to waste y'all's time on stuff like that on a Friday, especially on the last day. But if you do want to try it out, you can go to the ASCII practice. Let me just remove this. Oops. Delete. But it's a very simple, right? You're essentially just converting the characters and manipulating, just messing around with the OR and the chart function. If you want to try it out and you've never used ASCII, definitely give this a try. But I'm not gonna waste everybody's time on this one. But definitely try out ASCII practice if you've never seen it. And that's gonna be it here for today. That concludes everything for Foundations of Programming, right? We are officially done with everything. This is our class schedule. After the ASCII values, really it was just to pre-work challenges. But we're not doing those. We no longer have the 12 that we used to have before. Now it's just 3. But if you do want to see how far you've gotten, I recommend just go ahead and open up CoderBot and give those a try and see how fast you're able to finish this. I don't know how long it took for you guys to do your CoderBot challenges. If it took you a day or two, you might be surprised how much more efficient you are now than when you first started. It's always a confidence booster to see how much more you know now. From start to finish, what we've learned so far is actually a lot, right? When we came in, we learned about the terminal, Git, and GitHub. So you guys should have some kind of familiarity working with your Linux terminal, creating files, directories, navigating between them. We even created virtual environments. We worked with HTML, CSS, and JavaScript, all 3 concepts together. We made small little applications. You guys were able to work with APIs, put in API requests. We worked with product capabilities. You guys even got to work with object-oriented programming for almost like 2 weeks. You guys are significantly ahead of anybody else that you might start with come Monday. All right, so you guys are in a very good spot right now. And really, one of the things that really benefits you with being an FOP is that it puts you behind your screen, right? Which is a lot, right? It's more helpful than you actually think. And I say that because if you weren't here in Foundations of Programming, chances are, if you were just on your own, you probably wouldn't be coding every single day because you wouldn't have anything to code. You wouldn't know what to code. What should I be working on? What should I be practicing? If I finish all the pre-work, what should I be doing now? Right? So Foundations of Programming, thank you guys for showing up. For those of you that are here right now and making all the way through. This gave you something to work towards too. You got to see stuff that you're going to be tested on in the immersive program. You have an idea of what to expect. You have a baseline of knowledge already. So when you guys start the immersive program next week, you guys are going to be in a much better spot than anybody else. And really, I just want to thank every single one of you guys for showing up today, showing up consistent throughout the entire month. And then anybody that's still watching, thank you guys. But that's going to be everything. I'm going to go ahead and stop the recording now so we can open up a Q&A session.